What is going on, guys? Welcome to your fifth physics tutorial, and in this lesson I want to clear up some terminology that I've been meaning to do so for some time, but I just haven't gotten to it. And in this tutorial we're not going to be crunching a whole lot of numbers, but we're going to be learning some new vocab. Now, the first thing I want to talk about is the difference between velocity and speed. So, velocity, well, before I talk about velocity, I think it's better that we understand speed first. The speed of anything, as we already know, is basically how fast is that object moving. Is a car moving 5 miles per hour, or can you throw a baseball 90 meters per second? So basically, speed is how fast something's moving. But didn't you hear people talking about velocity before and it sounded a lot like speed? Well, it's true, velocity and speed are related in some sense, but the technical definition for velocity, and whenever we write velocity in formulas, we use a lowercase v. The definition for velocity is speed plus a direction. So let's go ahead and take a look at what would be a speed and what would be a velocity. Whenever we would want to give someone the velocity of something, we would first need a speed. So let's go ahead and steal this one, 5 miles per hour. And if someone was giving us the term 5 miles per hour, that would be a speed. But if someone said, okay, a car was traveling at 5 miles per hour and it was heading south, then since you have these two components of velocity, speed, which is 5 miles per hour, and direction, which is south, this would be equal to velocity. So remember that whenever you have velocity, you need two key components. Not only speed, but you also need, whoops, pointed to the wrong thing, speed and direction. So that is basically velocity. Again, just remember that velocity is like speed plus a little bit. So now that we understand the difference between velocity and speed, I want to talk to you guys about another term that people get confused a lot, and that's displacement and direction. So displacement, let me go ahead and write you guys the definition first. And I'm writing on the wrong layer. Great. Displacement. This is technically defined as distance plus direction. So remember that. That's the key to this lesson right here. So what do I mean by distance and direction? What the heck does that mean? Well, say we have a distance. Say we're, I don't know, pushing some toy cars around on the floor, and we move the toy car a distance of 8 inches. Well, that would be the distance, 8 inches. But now, in order to get the displacement, we need to know what direction we moved it in. And say we moved it not only 8 inches, but we also moved it west. So this was the original starting point for the toy car, and we moved it 8 inches to the west. So there you go. This would be displacement. So again, distance and displacement are related, but displacement is basically distance with the direction, similar to the idea that whenever we were talking about velocity and speed, velocity is speed with a direction. So basically, these terms are just, I don't know, the old terms plus a direction. Now, that's easy enough to understand, but physicists had to make things a little more complicated. So what they decided to do is they decided to break up these terms into something called scalar, SCALAR, and vector, VECTOR, quantities. Now, the easiest way that you can remember this is basically this. Whenever you have a scalar quantity, you're talking about one thing, and whenever you have a vector quantity, you're talking about two things. Typically, the size of something and the direction where it's moving. So, for example, we already know that speed is scalar, and the vector quantity would be velocity. So speed only has a magnitude, but velocity has a magnitude, such as 5 miles per hour, and a direction, such as south. Now, for displacement and distance, we can say things like distance is scalar because we can have a distance of, I don't know, 48 inches, but the vector quantity of that would be displacement. And the reason behind this is because displacement not only has a distance, such as 48 inches, but you need to give it a direction such as north, east, south, and west. So some other things that are scalar and vector, time, for example, would be scalar because you can't say 2 hours east. That doesn't make sense. And I can't even think of some vector ones right now, but later on we're going to be talking about vector and scalar quantities, and that's what I'm going to refer to. Whenever I say that speed is a scalar quantity or displacement is a vector quantity, just remember that. Whenever you're working with displacement, or if you're taking a test and your teacher's going to ask for velocity or displacement, make sure not only you give them a quantity, such as 5 miles per hour, but you also include the direction, which is northeast or whatever they're asking for in the problem. So there you go, there you have it. That is the difference between velocity and speed, and also distance and displacement. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.